Hello all. So today we are going to discuss about the basic functions of operating systems. So there are six: process management, primary memory management, file management, main memory management, IO system management, and secondary storage management. So first one, process management. So first and foremost thing, when we want to know the process management, first and foremost thing, we should know what is a process. A process is a program in execution. So as we all know that the operating system is a one which keep on executing programs one after the other, right? So that's why first and foremost thing, we should know the process, which is nothing but a program which is in execution. Then what are the processes that will be there in an operating system? They are a time shared user program such as a compiler, okay, is a process. Second one, a word processing program being run by an individual user on a PC is also called as a process. Then a system task such as sending output to a printer is also a process. Correct? So these are all considered as a process. Next, to execute a process, the OS needs includes CPU time, memory files, and I/O devices to accomplish its task. For example, if it has to give a output, a print, that mean what? It should use the I/O devices where the printer has been connected. So from the desktop or from the laptop, the print command is given, so that will go to communicate with the printer which is connected to I/O device. Okay, then the particular print option is executed, right? So that's why a process needs to have all the resources which is needed to execute a particular process. These resources are either given to a process, okay, when it is created, or else when allocated when while it is running. That means when the process is running, the resources will be allocated or else will be given during the starting point only. Then, what all the processes does the OS will do? First one is creating and deleting both user and system processes. Right? The OS, what it does, it creates and deletes both user and system processes. It also suspends and resumes some of the processes. Right? So it suspends and resumes some of the processes, providing mechanism for process synchronization, right? In RTOS, that is in real-time operating system, this synchronization word plays a greater role, right? What do you mean by synchronization? Synchronization is nothing but the process should be in time with the real-time clock. That is nothing but RTC, real-time clock. That means any process that it is running should be in phase with the time which is kept by RTC. That is nothing but real-time clock, which will be there in RTOS. Right? So OS should track the process, okay, and also should keep an eye on a process so that it can run according to the clock. That is real-time clock. Providing mechanism for process communication, right? Providing mechanism for process communication. So what does it mean? It means that if there are different processes are running, for example, you are having processes P1, P2 and all, okay, so you might be having different processes, okay. So now what will happen? There should be a mechanism which can allow the process for communication. That means there should be an intermediate communication between the processes, right? So now OS will allow or provides a mechanism where it allows the communication for different processes, and also provides mechanism for deadlock handling, right? So this deadlock handling is a bigger role, okay, in OS, right? So if lots of requests will come, so the OS will into a deadlock situation. So now the OS whatever is there which should be capable of handling, okay, a deadlock condition. The next one is primary memory management. Okay, so the term primary memory refers to the volatile memory, that's nothing but a RAM, right? So what is volatile memory? Volatile memory is nothing but a one which doesn't store the data if the power goes up, right? So that's what is nothing but volatile. Normally RAM is nothing but a volatile memory, right? So it consists of a memory management unit. In short, it is called as MMU of the kernel is responsible for. That means MMU is responsible for keeping track of which part of the memory area is currently used by which process. Now, As the memory is huge, now the point is that OS should keep track of the memory that is getting used and that is free into a computer system. So that will be done by a memory management unit, that is MMU. And also MMU is responsible for allocating and deallocating memory space on a need basis. Okay, so it allocates and might deallocates a memory space on a need basis. Then third one is file system management, right? So everybody is associated with a file. So what is a file? File is nothing but a collection of related information, right? So a file could be a program. Okay, so that program can be source code or executable. Okay, a file can be a text file, a file can be image file, a Word document, audio, video files, etc. Right? So these are all can be called as a file. It can be a text file, it can be an image file, it can be a Word document, or else it can be even video, audio files also. Right? So those are all also called as files. Each of these files depend on the kind of information they hold and the way in which the information is stored. The file operation is a useful service provided by the OS. The file system management service of the kernel is responsible for. Okay, so what is the file system management will do? Okay, so there are five process. It will do the creation, deletion, and alteration of files. Okay, so it will do creation, deletion, and alteration of files. It also does creation, deletion, and alteration of directories. And also the function of the file system is saving of files in the secondary storage memory, that is hard disk, providing automatic allocation of file space based on the amount of free space available, providing a flexible naming convention for the files. Okay, so these are all the operations that normally we will be doing in an operating system when we are using the computer systems. We can do it in even in general purpose computers, or else even we can do it in the real time operating system, right? So these are all the operations we can do it. The various file system management operations, okay, are OS dependent. Okay, what do you mean by OS dependent? The file that we handle in Microsoft and the file that we handle in Unix are different. Okay, the way that we handle are different. So that's why the file system management operations are different in different OSs. They are all OS dependent. Then IO system device management. The fourth one is IO system device management. Kernel is responsible for routing the IO requests coming from different user applications to the appropriate IO devices of the system. Right now, for example, let us consider that we are having one microcontroller over here, and to this microcontroller we are having some sensor. Okay, and to this we have connected a DC motor. Okay, and then we have connected one stepper motor. Right. So let us assume that this sensor, based on we are having two sensors over here. Let us, this one is S1 and this one is S2. Both are connected to microcontroller. This, the capable of this sensor is that it can rotate the DC motor, and the process of this stepper motor, this sensor is that it should rotate the stepper motor, right? Now, the OS which is there in this microcontroller should be able to route, okay, the request of S1 to DC motor and S2 to stepper motor. That's what is defined, right? So the kernel responsible for routing the IO request coming from different user applications to the appropriate devices, right? So for example, S1 and S2 are the two user applications that request a DC motor and stepper motor. So this microcontroller is responsible for doing it. In OS, the direct accessing of IO devices are not allowed, and the access to them are provided through a set of application programming interfaces, that is APIs exposed by the kernel. Okay, so it means that to access the IO devices directly, it's not possible. For that, we should use some APIs called as application programming interfaces. Okay, so that we can access the IO devices. For example, in C program, there are different libraries are there, library functions or header files are there. Those have to be included so that we can access the particular files, right? Otherwise it becomes difficult to access the files, because OS directly doesn't allow to access the IO devices. The kernel maintains the list of IO devices of the system. The list may be available in advance at the time of building the kernel. Some kernels dynamically updates the list of available devices as and when the new device is installed. Okay, For example, whenever we connect a USB drive to a particular USB port, okay. So the general purpose computer in the computer, my computer icon will show that to which IO port or USB port is used. Okay, so that it means that the OS will update the information on its own whenever a particular USB has been connected. Okay, that's what been has been dealt over here. Then we are having secondary storage management. The main purpose of the computer system is to execute the programs. Right? So this is the main purpose, right? To execute the programs, we need to have memory. We need to have memory systems, right? So this is what which is needed to execute a program. These programs use the main memory during the execution, right? So as we know that the data stored in a main memory is used by the computer for execution. Now, what is the disadvantage? The disadvantage is that the main memory is too small to accommodate all data programs, and also the main memory is volatile in nature. Okay. So the computer system must provide the secondary storage to back up the main memory. Most modern computer systems are disks as the storage medium to store the data and program. Right? It means what? The secondary management is required for any of the computer systems to hold the data. If the secondary storage management is not there, then the storing of the data becomes difficult. Okay, as well there is a main memory will be there, but the point is the main memory will be very small. Okay, and it is volatile in nature. So that's why today's computers comes with somewhere around, okay, if there is an 8 GB RAM, which is nothing but a main memory, okay, then you can find out that the storage secondary storage will be somewhere around in 600 GB, or else it will be somewhere around 1 TB, 1 terabytes. Okay, so 1 terabytes. Here only we can come to know that the main memory whatever is there, it's very small, whereas the secondary memory will be in terms of terabytes or gigabytes. Okay, it will be very very high. Okay, so that's why it shows that the data which once executed will be stored into the secondary memory. Also, the primary memory is volatile in nature, and the secondary memory is non-volatile in nature. Then the operating system is responsible for following activities of disk management. So free space management, storage allocation, and disk scheduling. These are all again it will be done by the operating system. Because secondary storage is used frequently, it must be used efficiently, right? So secondary storage, whatever is there, as we told, okay, normally it will be provided as a very high capacity. Okay, so that's why it should be used efficiently. Okay. There are again some of the basic functions are there, okay, which is done by computer systems. First one is networking. Okay, so what is networking? A distributed system is a collection of processors that don't share memory, peripheral devices, or a clock. Okay, each processor has its own local memory and clock, and the processor communicate with one another through various communication lines such as high speed buses or network. The processors in the system are connected through communication networks, which are configured in a number of different ways. The communication network design must consider message routing and connection strategies are the problems of connection and security. What does it mean? Okay, it means that let us consider a system called as ATM, right? So ATM is a machine that we use in our day-to-day life, right? Now, this ATM machine will be having different processes. The first process is a card reader, second process is money counting, and third one is money dispensing, right? So let us consider that there are three microcontrollers are there. So this is M1, this is M2, okay, and this is M3. So there are three microcontrollers are there. Okay, so they are nothing but M1, M2, and M3. First one is to read the card. Second one is to count the money. Third one is to dispense the machine. Right? Now, so as these processors are connected, okay, are have to will be put on a particular chip. Will be put on particular. So that's why they have been called as distributed. Right? So because the processors are distributed, okay, so they are separate. So they have been called as distributed. Now, each processor has its own local memory. So this will be having its own local memory, this will be having its own local memory, and this also will be having local memory. And the clock provided to that processors will be again different. Okay. So that's why it has been dealt that Okay, so the clock and the processor communicate with one, so they are being different, and also they have been connected together with some communication, right? For example, over here, whenever M1 reads the data, for example, card reader, whenever it is correct, it should tell to the M2 that it is correct, now count the money, and then M3 will dispatch. Now they have to be connected through buses. They have to be connected through buses, right? Now these buses either can communicate faster or these buses can communicate at a slower rate. Okay, it depends on what application we are using. If we want the process should be fast, then we should go with a fast communication, or else we will go with a low communication buses also. Right? So that's what has been done over here. Next one, protection or security. If a computer system has multi-users and allow the concurrent execution of multi-processes, then the various processes must be protected from one another's activity, right? So suppose by chance, if I am having one microcontroller, okay, and that is getting used by different processes, okay, the care has to be taken that these processes should not have to get mixed. Okay, so that's what has to be protection and security. For that purpose, mechanisms ensure that the files, memory segments, CPU, and other resources can be operated on only by those processes that gained proper authorization from the OS, right? So we are having two processes over here. So if they are getting executed, now the OS should authorize this first process, telling that this process is getting executed. Whenever it authorizes it, okay, there is the OS should allocate all the resources to this process only, so that this P2 doesn't get any resources from the hardware, and that mean what, there is no data mixing up from P1 to P2 will happen. So the last one is command interpretation. So one of the most important functions of the OS is connected interpretation, where it acts as the interface between user and the OS, right? Suppose if the user has given some commands, so OS has to interpret it and has to do the particular operation. So thank you. We'll cover the next syllabus in the next video. Thank you.